Alrighty, so now we're going to get started on the second part of our presentation, which will be the going through the greatest hits and the multiple choice. So basically, I just picked 6 of the most missed questions on the MCQs. Of course, this is going to represent all of the MCQs that you'll see on the magnetism part of the test. But of course, this is just what was most missed on the MCQs. So try to look at everything if you can and everything you missed, but these are just general things. So we'll start with this question where it's electrons moving through a wire between the poles of a magnet going from north to south. So we know that the electric field is going from top to bottom. But the thing that was missed with this question was people using the right-hand rule instead of the left-hand rule. So if you use the right-hand rule, the force will be going into the page, and left-hand rule will be coming out of the page, which will be the right answer. If you want to go, Josh. Yeah. So it's just kind of a simple mistake that's easy to make. It's just making sure you know which right-hand rule or which hand rule you're using. This is a similar one. It's dealing with a current through a ribbon and then going between a magnet again. So basically, we know that it's just kind of direction of force. So we know, yeah. So we know that A has a higher potential. So that basically means that more positive charges are moving towards A, and when negative charges are moving through B. So we just move to the answer. So yeah, electrons are going to experience a force to the right that it deflects them towards B, which will create a higher potential at A than B. So basically, it's left-hand rule again in a way for electrons. So we just have to think, since mostly answers are talking about electrons, then we have to think about that and also what it means to have higher and lower potentials. And then for question 24, this is a torque question. So basically, this is just kind of a conceptual question when you're thinking about how current affects torque and what affects the torque. So it's using the equation that we talked about before, Bain, and we can go move to the answer. So yeah, it's just if the measured current is less than the actual torque, that is the non-experimental torque is greater. But this is also kind of a reading question, of course, just like a lot of multiple choices on the AP Classroom. Just make sure you're reading the right answer. But it's just kind of thinking about how more or less current will affect the torque. And then for this question, for question 27, we're thinking about just kind of magnetic fields from current carrying wires. So it's kind of just using your right hand rule for the current and seeing, just kind of imagining the field going around and what direction it's going. So for wire 1, it'll be coming out of the page in between the wires. And for wire 2, it'll also be coming out of the page because the current is moving in the opposite direction. So the answer will be E. So yeah, this is also just making sure you're reading the right answers and making sure that everything in them will make sense instead of just a couple things. For question 31, this is kind of a concept thinking about. So essentially, we're thinking about the ratio between the both areas, both the cross-sectional areas. So we can move on to the answer. So we're thinking of the ratio of the cutout part to the top part. So it is going to be, so we know that B dot dl is Ampere's law, which is mu naught I, and then the I will be the circular part over the square part, which is kind of a conceptual thing, but it's easy to mess up. And then question 33 is pretty simple. It's kind of just knowing that um, angle of an Amperian loop outside a wire doesn't matter. It only matters inside a wire. So you know that if the Amperian loop is outside the wire, there's no x and y components to the magnetic force. It'll all be the same around. So it'll just be I, or magnetic field, not magnetic force.